In the very first question you have, the first example, you're asked, where on the graph does it show the population of Pittsburgh is the same as that in Las Vegas? Basically, you're looking for the solution to the system of equations or the system of the two functions that represent population versus time. And of course, that's where they intersect each other. And that's happening right here. So it looks like in about the year 1994, where there's approximately 350,000 people in both cities, that is where you want to point to in the example that you have in Top Hat. As far as finding out what is the solution to a system of linear equations, basically you're looking for an XY pairing that satisfies both of them. So when you look at the choices that you're given here, negative 2, 6, if you substitute that into the first equation, you see that the left-hand side becomes 30, which is not the same thing as 17. So as a result, this is not a solution. If you go to 4, negative 1, and substitute the x and y values in respectively, you do get 17 on the left-hand side. So that does work. That is a solution to the first equation. The second equation, you do the same because it has to work for both. And it does work. It does make 22 on the left-hand side, so this is a solution to the equation. Now, typically, you're only going to have one if they are straight lines, so the rest of these other two should not be solutions, but let's look at why. Negative 3, 5, if you substitute negative 3 in for x and 5 in for y, you do get 17 on the left-hand side, so it is a solution for the first equation. But for the second equation, if you substitute it in and carry through calculations, you get 9 on the left-hand side when you want it to be 22. So that's why it's not a solution. It doesn't satisfy the second equation, even though it does satisfy the first. And of course, 13, negative 7, if you start with the first equation, you see that it's not going to work for that one either. So just looking at the first equation, it's not going to be a solution to the system of linear equations. And so you're asked a very similar question because you're told that 4, 2 is not a solution for the system of equations. You're asked why? What's the reason? So if you substitute 4, 2 in, you do get 32 on both sides. So 4, 2 is a solution to the first equation. If you substitute into the second equation, however, it doesn't work. And ultimately, that's why it's not a solution. It's not a solution because 4, 2 is not a solution to the equation 5x plus 7y equals 11, and since it doesn't satisfy both of them, it's not a solution to the system of equations. In example 4, again, you're just asked, well, where is the solution, or what is it, to the system of linear equations graph below? Well, if you have it graphed, and it's actually, they're intersecting at this point, and it's an easily determined point, you can see it's 1, negative 1. You don't know what the equations are to verify it, but as long as you have a graph and the point is easily known set of coordinates, then graphing is a good way to go. Unfortunately, a lot of times you're going to have situations where two equations intersect. The point is not going to be at a set of coordinates where necessarily you're going to have integer numbers all the time. It might be like a point that's like intersects like right here in the middle of a grid, and you're going to have to try to guess graphically what it is unless you have it scaled correctly. So there are algebraic ways of determining that, and that's what the next demonstration actually gets into. So, but for the time being, that's the end of this video. If you have any additional questions, please make sure to bring them up in class.